In an earlier section, we used angles and standard position to define the trigonometric functions. Our second look at the trigonometric functions is from a right triangle perspective. Hello, my name is Tom Atwater, and in this section, we will evaluate trigonometric functions using the familiar right triangle. Let's look at the right triangle-based definitions of the trigonometric functions. Using this triangle, we have an angle in standard position. We have our values x, y, which represent the point xy on the terminal side, and we have the hypotenuse of the right triangle as r, the distance from the origin to the point xy. In that case, the sine of angle A is equal to, well, we know it's y over r, but in particular for the right triangle, it's the side opposite over the hypotenuse. For the cosine of angle A, it's the side adjacent over the hypotenuse. And for the tangent of A, it's the ratio of the side opposite to the side adjacent. For our three reciprocal functions, cosecant of A is equal to the hypotenuse over the side opposite. The secant of A is equal to the hypotenuse over the side adjacent, and the cotangent of A is equal to the side adjacent over the side opposite. Let's use our newfound definitions to find the trig functions for the values in this following example. Find the exact values for the 6 trig functions of angle A. So, using our new definitions, we know that the sine of angle A is equal to the side opposite it divided by the hypotenuse. So, sine of A is the side opposite over the hypotenuse. When we look at our diagram, let me draw that diagram for us. We have a triangle in which this is the right angle up above. And we know that this side is 21, this side is 20, and that side is 29. The angle A that we're dealing with is right here. So when we want the sine of angle A, we want the side opposite it, 21, over the hypotenuse. So the sine of A is 21 over 29. Next, we'll find the cosine. The cosine of A is the side adjacent. Well, adjacent to A is 20. Divided by the hypotenuse is 29. So that's our cosine. The tangent of A is equal to the opposite over the adjacent. So for our angle, opposite is 21, adjacent is 20. For the cosecant of A, well, remember that we can look at that as simply being the reciprocal of the sine of A, or with our newfound definitions, it's the hypotenuse over the opposite. So the hypotenuse is 29, the opposite is 21. What about for secant A? For secant A, that's going to be the hypotenuse over the side adjacent. The hypotenuse, of course, is 29. The side adjacent is 20. So for secant A, it's 29 over 20. And finally, for cotangent of A, we've said that that is equal to the adjacent side over the opposite side. And so the adjacent side is 20, and the opposite side is 21. So that would be the 6 trig functions based on the new definitions from right triangle trig. Now, there are certain angles in trigonometry that are used so often, such as 30 degrees, 60 degrees, that they deserve special study. Let's develop triangles containing those angles and then use them to find the trigonometric function values for those angles. So we have what's called an equilateral triangle. All three angles are 60 degrees, and all three sides are equal to 2. If I drop a perpendicular from the angle at the top and divide it into two triangles, you'll see that the two triangles are congruent. They are what we call a 30, 60, 90 triangle. And we can find the value of x by using the Pythagorean theorem. So let me do that for you. We have a right triangle, which is 30, 60, 90. That side is 1, this side is 2, and this side is x. So we can set up that 1 squared plus x squared equals 2 squared. And that means x squared equals 4 minus 1, which means x is equal to the square root of 3. We only take the positive root because, of course, we're dealing with the length of the side of a triangle. So our triangle then has the three sides, 1, square root of 3, and 2. And therefore, to find the 6 trigonometric functions, it's straightforward now. For example, let's start with the 30 degrees. The sine of 30 degrees would be the side opposite divided by the hypotenuse. The cosine of 30 degrees would be equal to the side adjacent over the hypotenuse. The tangent would be the side opposite over the side adjacent. So the tangent of 30 is equal to, well, originally it's 1 over the square root of 3, which when we rationalize the denominator gives us square root of 3 over 3. Of course, we could continue and find the cosecant, secant, and cotangent, but they are just the reciprocals of the three functions that we have in front of us. In addition, we could find, for instance, and I will do this one, the sine of 60 degrees. The sine of 60 degrees will be the side opposite it over the hypotenuse, square root of 3 over 2. I'm not going to continue, but we could go through and find the cosine of 60, the tangent of 60, as well as all the reciprocal functions. But that's how you can use that special triangle to find the trig functions of 30 and 60. Now let's take a look at the 45, 45, 90 triangle. What we have this time is an isosceles triangle where the two legs are each equal to 1. The two angles that are in the non-right angle are each, of course, 45 degrees, and that means that r is equal to the square root of 2. So if I wanted to then find the trig functions for the 45, 45, 90 triangle, I would simply say that the sine of 45 degrees is the side opposite over the hypotenuse. When I rationalize the denominator, I get the square root of 2 over 2. Cosine of 45 degrees. Well, it's the side adjacent, 1, over the square root of 2. Rationalize it, and we get square root of 2 over 2. Yes, in fact, the sine of 45 degrees is equal to the cosine of 45 degrees. They both are the square root of 2 over 2. Let me do one more, the tangent of 45 degrees, which would be the side opposite over the side adjacent, 1 over 1, which is 1. Let's solve an example using one of the special angle triangles. For the expression secant of 30, find the exact value and use your calculator to support your answer by finding a decimal approximation. So we want to find the secant of 30. So let's draw our 30, 60, 90 triangle. Remembering that opposite to 30 is 1, adjacent to the 30 is the square root of 3, and the hypotenuse is 2. We want the secant of 30 degrees. The secant of 30 degrees is either think of it as the reciprocal of cosine, or if you've memorized the secant, it's going to be the hypotenuse over the adjacent. So the hypotenuse over the adjacent, rationalize that denominator, and you get 2 square roots of 3 over 3. So now let's go to the calculator and get the approximate value based on the calculator, whereas this is an exact value where we leave it as the square root of 3. So on the calculator, what we have is we want to evaluate 2 times the square root of 3, so the secant followed by the x squared key. We type in the 3, close the parentheses, and then we want to divide that by 3. Pressing enter gives us 1.154700538, and that's our approximation because, of course, this is an irrational number. It continues on forever, and therefore that value is just an approximation for us. Now, let's look at this next triangle and observe some interesting relationships. Notice that if we look at the sine of angle A, here's angle A right here. And if we look at the sine would be A over the hypotenuse, which is C. Well, interestingly enough, what if I turn this around and say, let's look for the cosine of angle B. Here's the cosine of angle B, and notice that cosine is the adjacent side, which would be A, over the hypotenuse, C, which is the same exact value that we got for the sine of A. And the relationship between A and B is that they are complementary. That is to say, that the sine of 90 minus B is equal to the cosine of B. These are called co-functions. And they're co-functions in that they relate to one another. That is, the sine and cosine are co-functions related by the fact that the angles of a right triangle that are the non-right angles are complementary. Well, let's continue along and notice that we can find the co-functions for all of the trig functions. And here they are. Cosine of theta is equal to sine of pi over 2 minus theta. Sine of theta is equal to the cosine of pi over 2 minus theta, and cotan theta is equal to the tangent of theta tangent of pi over 2 minus theta. We also have tan theta is the cotan of pi over 2 minus theta. Cosecant theta is equal to secant of pi over 2 minus theta. And then finally, the secant of theta is equal to the cosecant of pi over 2 minus theta. In our next example, we will write an expression in terms of a cofunction. So our example then is, write the expression cosine of pi over 5 in terms of its cofunction. So we have cosine of pi over 5. And what we know is cosine and sine are cofunctions. So this would be the sine of pi over 2 minus pi over 5. And we need to have a common denominator, which in this case would be 10. So this would be the sine of 5 pi over 10 minus 2 pi over 10. That gives me the sine of 3 pi over 10. So that means that the cosine of pi over 5 will equal the sine of 3 pi over 10. Well, let's use the calculator just to check that, in fact, the cosine of pi over 5 equals the sine of 3 pi over 10. So on the calculator, let me clear that out. Let's first find the cosine of pi over 5. So cosine, and then we put in secant pi divided by 5, close the parentheses, hit our enter, and we get 0.8090, etc. Well, now let's do the sine of 3 pi, so 3 times secant pi divided by 10. Close the parentheses, hit enter, and lo and behold, we get 0.8090 continuing. So in fact, the calculator supports what we found using the cofunction identities. Well, so far we have found the trigonometric function values when it is an acute angle. But what if the angle is greater than or greater than 90 degrees, yet less than 180 degrees? Well, then the trigonometric function values can be calculated using their values at the corresponding acute angle, which is called the reference angle. Here's the definition that we will use. Let theta be an angle in standard position. Its reference angle is the acute angle theta prime formed by the terminal side of theta and the x-axis. So I have a figure in which I want to look at finding the reference angle in each of the different quadrants. So let's start with quadrant 2. So in quadrant 2, we have the terminal side of the angle right here. And theta is, of course, this blue angle. And so the reference angle, theta prime, would be this angle right here between the terminal side and the closest part of the x-axis. So that's an angle in quadrant 2. What about an angle in quadrant 3? Well, in quadrant 3, here's the terminal side of the angle, and here is my reference angle, again, between the terminal side and the x-axis. Well, the only other one we need to do is, of course, quadrant 4, where we will have that the reference angle is between the terminal side and the closest part of the x-axis. Well, in the next exercise, we will find the exact value of the trig function values by using a reference angle. So, find the exact values of the 6 trigonometric function values for the given angle by hand. In other words, don't use a calculator, simply do that using reference angles and the special triangles that we've already looked at. The first thing to do then is to figure out what the reference angle is by drawing the original angle. The original angle is 300 degrees. So the reference angle then is 60 degrees. And we draw this triangle. So what, of course, we realize is that it's the 30, 60, 90 triangle. And with the 30, 60, 90 triangle, the hypotenuse is 2. This side is the square root of 3. And the x side is equal to 1. This point, however, is 1 comma negative the square root of 3. Again, that's telling us that the y value is negative in quadrant 4, so any of the trig functions that involve the y value will be negative. So let's find the sine of 60 degrees. The sine of 60 degrees will be the side opposite over the hypotenuse. Well, the side opposite is really negative the square root of 3 over 2. So that's the sine of 60 degrees would be positive square root of 3 over 2, but the sine of 300 is going to be negative the square root of 3 over 2. So that reference angle, of course, will always give us a positive value, but when we actually take into account where the point lies, in this case quadrant 4, that is what applies the positive or negative sign to the trig value. What about the cosine of 300 degrees? Well, the cosine of 300 degrees refers to, again, the reference angle is 60. It's the side adjacent divided by the hypotenuse, or in other words, 1/2. And of course, the cosine is positive in quadrant 4. Now let's find the tangent of 300 degrees. And the tangent of 300 degrees, we look to our reference angle, which is 60. So that triangle, it's the side opposite over the side adjacent. But again, in this particular case, tangent is negative in quadrant 4. So it's negative the square root of 3 over 1. Or in other words, just negative square root of 3. Well, for the 3 reciprocal functions, we can simply take the reciprocal of these. And so for cosecant of 300 degrees, it's equal to negative 2 over the square root of 3. We need to rationalize that denominator. So that would be negative 2 square roots of 3 over 3. What about the secant of 300 degrees? The secant of 300 degrees is the reciprocal of cosine, 2 over 1, or in other words, 2. And finally, the cotangent of 300 degrees is simply the reciprocal of tangent, so it's 1 or negative 1 over the square root of 3. We have to rationalize that denominator, so it's negative the square root of 3 divided by 3. All right, so that's how to find the 6 trig functions using the concept of reference angle. Now I would like to give you the opportunity to find a trig function value using reference angles. Here's the problem. Find the exact value of the sine of the given angle by hand. Theta is equal to 405 degrees. Pause the video while you work on this problem, and when you are finished, restart the video to check your solution. All right, let's find out how you did on this problem. We have the angle of 405 degrees. So that would be, once around is 360, I have to go an additional 45 degrees. And that would give me a total angle of 405 degrees. Drop a perpendicular, and I realized that with the reference angle, which is in fact 45 degrees because the angle from the x-axis to the terminal side is 45, that I have my special right triangle of 1, 1, square root of 2. So now what we want is the sine of 45 degrees, which equals the opposite over the hypotenuse, which when we rationalize would be the square root of 2 over 2. But then the sine of 405 degrees would be the same as that with the appropriate sign. But we know that all of the trig functions are positive in quadrant 1. So, of course, the sine of 405 is equal to the square root of 2 over 2. I hope that's the answer that you got on that problem. Now, it is often necessary to find the angle when given the value of the trigonometric function. And in doing so, we use the inverse trig function using keys on a calculator. The keys on the calculator are marked with sine inverse, which looks like this, or cosine inverse, or tan inverse. So those are the actual keys on the calculator that we'll use in the next example. Find the angle theta for which a 5,000-pound car has a grade resistance of 400 pounds. Use the equation that F equals W times sine theta. All right, so in the equation F equals W sine theta, what we know is W is the weight and F is the resistance. Theta is the angle of the incline. So, for example, here's my theta. This is the incline. I form that right angle. And so I'm looking for this angle theta, and what I know is that the resistance is 400, the weight was 5,000, and we don't know, of course, the sine of theta. So sine theta, though, is going to equal 400 divided by 5,000. Then what we do is use the calculator by plugging in the inverse of the sine for 400 over 5,000. Of course, to make it a little bit easier, we can reduce this down, and it reduces down all the way to 2 over 25. So now let's go to the calculator and find, sine inverse of 2 over 25. So on the calculator then, what we do is we do secant sine, and you'll see that that gives me a printout of sine inverse parenthesis, and now what I plug in is 2 divided by 25, close the parentheses, and then hit enter. What I get then is 0.0808558, etc. And that is in radian mode. And in radian mode, we would want to get a sense of what that is in degrees. So we can convert that over, and you'll see that it works out to approximately 4 6/10 degrees. So that's the angle theta of the incline in order for a 5,000-pound car to be acted upon by a force of gravity of 400 pounds. All right, great work in today's lesson. There was a lot that we looked at today. In fact, in this section, we have evaluated the trigonometric functions using right triangle trig and reference angles. To fully appreciate what you have learned, be sure to work the exercises that your teacher assigns, and we'll see you next time.